Good morning. We're gonna wait another minute or two just to let people trickle in. But oh my God, I didn't admit everyone. Sorry, one second. Good morning, everyone. Thank you all for joining. We're just gonna give it another minute or two, let everyone kind of trickle in. But thank you for joining April's threat briefing with Novacoast. We're excited to have you guys again. Or if this is your first time, thanks for joining. We'll start around 10:02. All right, I will hand it off to Bryce. Again, thank you guys for joining the April threat briefing. We're excited to have you. Feel free to save the questions you may have until the end, and I'll go through the chat, the Q&A section, and make sure we get all your questions answered. All right, handing it off to Bryce.
Thank you. Good morning, everyone. Thanks for joining the threat briefing today. As always, the briefing objectives are to highlight the malware, targeting, and threat actor trends that we've seen this month, as well as identify proactive measures and mitigations against those. Um, Before we dive into the threat landscape for this month, I just kind of want to touch on a little bit of an update from last month. So last month we touched on the Iranian hacktivist groups that were targeting exposed ICS equipment. And this week, six different federal agencies issued a joint advisory confirming that that has become a reality. So we've seen active disruptions to water, energy, any and every type of ICS equipment. Um, so we'll touch a bit on that in this slide, but I just wanted everyone in the room to treat that as kind of a standing action item. Um, so diving into this month, the threat landscape has a clean through line. So everything that we've seen is really based on exploiting trust in the environment. That's true whether we're talking about a China-linked ransomware group that's exploiting a zero-day in your email server, a North Korean espionage campaign hiding in GitHub traffic, or a separate North Korean group hijacking an NPM package your developers install without thinking about it. I want to touch on to the North Korean dual track before we get into the campaign specifically. Um, they're using GitHub as a C2, and a separate group has compromised the Axios NPM package. These are the same nation states running completely separate playbooks against completely separate targets at the same time. One is more of a precision espionage operation, and the other is a mass scale supply chain attack. Um, if your threat model says, well, we're not a North Korean espionage target, so we don't need to worry, this month kind of invalidated that. The NPM attack specifically hit developers at organizations of every size and type. Uh, so diving into the first campaign that we're going to look at today, and that is the Storm 1175 group using Medusa ransomware. Uh, So this group isn't doing anything necessarily exotic for initial access. They're scanning for vulnerable instances of enterprise software your organization likely runs. So things like email servers, transfer tools, remote access platforms, and exploiting CVEs. What's noticeably different is the timeline. Um, we've seen cases where they moved from the initial exploitation to full-blown ransomware deployment across the entire environment in 24 hours. For most IR teams, 24 hours is barely enough time to triage an alert, let alone contain an active intrusion. The zero-day angle is also worth calling out, um, specifically the Smarter Mail CVE mentioned here is a widely used email and collaboration platform. This was actively being exploited by Storm a full week before the vendor disclosed it or a patch existed for it. If you run Smarter Mail, there is no patch cadence that would have protected you. Your only defense in that window was behavioral detection or network isolation of the platform. And that is the implication of a 24-hour deployment timeline combined with zero-day exploitation. Patch management alone is no longer sufficient. So diving into the technical details of this campaign, the kill chain has a few steps that I want to highlight specifically because they map to detection opportunities. So the Veeam credential recovery is the most underreported detail. After gaining domain admin access, they run a script that extracts the stored credentials Veeam uses to connect to backup targets. In most environments, Veeam has credentials for essentially every server it backs up. That means that one compromised admin account becomes credentials for your entire infrastructure. From there, PDQ developer pushes Medusa to everything simultaneously. If they use group policy instead, every domain joined system gets the ransomware at the same time. There's no staged rollout to detect it. It happens simultaneously. Um, Another thing that is worth calling out is the Cloudflare tunnel rename. They are taking the legitimate Cloudflare tunnel binary and renaming it to conhost exe, which is a real Windows process. So process monitors see what looks like normal system process. The behavioral tell for this is the network destination. Um, so the renames conhost.exe making TLS connections to Cloudflare uh, is definitely anomalous. So EDR network monitoring uh, behaviorally will catch this if it's tuned to flag process name to destination mismatches. And that's definitely something very important to implement in your environment here. Moving on to a bit more of the technical details here. Um, Sorry, we skipped a little bit here in the first part. So moving a bit back to before the Veeam backup happens, they're initially using LSAS memory dumping via Mimikatz. And then for lateral movement throughout the environment, lull bins are huge. So tools already existing in your environment, things like PowerShell, PSExec, and Impacket. Um, Another important thing to call out is with the Cloudflare tunnel binary, um, if RDP is blocked, the attacker will just modify the Windows firewall policy directly with the admin credentials that they've gotten. For data exfiltration, they use BandyZip for file collection and then rclone to sync the data to attacker-controlled cloud storage. They're also using double extortion, and this is leveraged before the encryption begins. Uh, so then moving on to the detection mechanisms for this campaign. Um, it follows the kill chain, so ideally catching it at the earliest possible stage, because the later you detect it, the less time you have before encryption happens. Your earliest and most reliable indicator is the LSAS access. Uh, the storm group is dumping credentials very early after initial access, before lateral movement, before ransomware staging. That's typically the first thing that you're going to see. If you catch that process access event, you have a window measured in minutes to tens of minutes to isolate the host before credentials are exfiltrated and then used for lateral movement. I would recommend configuring this alert to your highest severity tier, and it should generate an immediate page or call out, not just a ticket. Um, Another important detection mechanism here to touch on is the PDQ deployer alert. This is kind of your last stage warning. It means that you're seconds from mass encryption. If you're seeing this executing, specifically a script called run file copy.cmd from a non-standard path, the correct response here is immediate network segmentation, excuse me, network segment isolation, not investigation. At this point, you would want to investigate after containment, not during active deployment. Um, sorry. Another important detection mechanism here, again, the firewall policy modification, as that's often something that we're seeing. So alerting on any NetShell or PowerShell commands that are enabling RDP via the Windows firewall, especially from any accounts that are not your named firewall admins. For the hardening and response against this campaign, Um, I would highly recommend implementing a 72-hour patch SLA. So every one of these CISA key listed vulnerabilities, especially on internet-facing systems, as that's what they're primarily going after here, I would treat those as a 72-hour remediation SLA. Um, Again, a lot of these 0 days, kind of as we mentioned earlier, don't get disclosed before they're exploited. But the sooner that you are remediating these, the better off you're going to be. Um, the second big thing here is Veeam isolation. So backup the service, any backup service account credentials absolutely must not be shared domain credentials. Additionally, isolating Veeam so that a compromised domain account can't query or reach backup structure really helps protect against this. Um, Enabling ASR rules, so things like block credential stealing from LSAS, block process injection, those kind of things will be really beneficial as well. And the last thing that I would recommend here is having an internet-facing application inventory. So essentially just being aware and knowledgeable of every application in your environment that you have exposed to the internet. That definitely helps and kind of ties into the first point here of the 72-hour patch SLA. Just the more cognizant of all the different internet-facing applications in your environment, the easier it is to kind of keep tabs on these and stay ahead of it. Um, Moving on to the second campaign here. This is one of the North Korean espionage campaigns that we're seeing where they are using GitHub as C2 infrastructure. Um, So the threat actor group here is a North Korean state-sponsored group. Um, as I mentioned, they're using GitHub as C2 infrastructure, and this is clever for a specific reason. It doesn't just evade detection, it actively leverages your trust infrastructure against you. Your security team has probably made a conscious decision at some point that github.com is a safe domain. It's most likely in your developer allow list. Your proxy will pass it without inspection. Your firewall won't flag it. So by routing their C2 traffic through GitHub, the threat actor inherits all of that trust. The malware isn't communicating with a suspicious IP in a foreign country. It's talking to github.com, which would, appear the same as your legitimate developer tools. Um, the broader observation too is definitely worth calling out that the GitHub accounts that are used in this campaign span some of the most widely downloaded NPM packages. And this kind of does bridge into the third campaign that we'll talk about. Um, so again, just to kind of call out that these North Korean state-sponsored groups aren't running isolated operations. They're systematically working through open source ecosystems and using those as an attack surface. The attack chain here is rather deceptively simple, but that simplicity is exactly the point. Um, so instead of depending on complex custom malware, they're using native Windows tools for deployment, evasion, and persistence. So by minimizing the use of dropped process executable files and leveraging lol bins, the attacker can target a broad audience with a pretty low detection rate. Um, so essentially, they're not writing sophisticated malware because they don't have to. A PowerShell script that would beacon to GitHub and a scheduled task that runs a Python script, both of those things your legitimate software does constantly. And the only way to distinguish malicious from legitimate is behavioral context. So things like which user ran it, from what directory, at what time, communicating with what repository. All of those things are going to be useful in distinguishing between normal legitimate activity and malicious activity. Um, the anti-analysis check here is also worth noting for any of your threat hunting teams. If the malware detects a VM or a debugger, it terminates cleanly. So malware that runs in your sandbox will appear benign. You most likely won't catch this in an automated sandbox analysis. You will catch it in behavioral telemetry from real live endpoints. Um, More on the attack chain here. As I kind of touched on, they're using scheduled task. Typically, we've seen it done via XML task schedulers, and they're creating hidden folders as well, um, typically renaming things. So one that we've often seen is C/Winder, like Windows directory, but they add an extra R at the end. They're using other directories too, but intentionally misspelling them in a way that if you're just going through quickly, you might not notice. So that's definitely something to call out, and we'll touch on that a little bit in the detection portion as well. Um, and another thing to call out here as well is that there's another variant that we've seen of this exact attack chain, and that's the Scarcruft variant, which is a parallel campaign. And in the initial access, they're shifting away from using link files to HWB OLE based droppers. So what that essentially means is that they're actively iterating on evasion techniques. The more information that becomes publicly available about these, they're shifting those constantly to continue being able to gain initial access and a foothold in the environment. Detection for this campaign, as previously mentioned, focuses on behavior because there's no malware signature to catch. So a PowerShell script and scheduled task are not inherently suspicious. Everything depends on the context. The most actionable detection for most environments is the scheduled task query. So tasks created by non-IT user accounts, pointing to scripts in user writable directories, or as I mentioned, the Winder staging path specifically. Um, the They're using system path mimics, which, like I mentioned, are similarly named but intentionally misspelled, hoping that you won't notice. Um, on the GitHub C2 detection, it's most likely that you cannot and should not block github.com, but you can apply process to destination correlation in either your proxy or EDR telemetry. A Python process making outbound HTTPS connections um, to, api.github.com on a machine that's in your finance or HR department, that would definitely be an anomaly to hunt deeper on. And for the hardening and response in this, um, implementing things like link execution policies, so blocking any link files that are delivered via email, um, blocking them at the mail gateway, and flagging any link attachment for user review rather than having it auto deliver. Um, Implementing script interpreter control, so restricting execution of Python, PowerShell, VB script on non-dev endpoints, and kind of as I just mentioned, uh, proxy behavioral monitoring. So configuring alerts for GitHub's connections to any non-developer processes or endpoints, essentially anything that shouldn't be talking to GitHub. And I also recommend building out a baseline of all the scheduled tasks that you have running in your environment by both host and account, as this will then make it a lot easier to detect any anomalous scheduled tasks. Moving on to the third and final campaign here is the Axios NPM supply chain attack. Um, so this happened actually March 31st going into the 1st of, so the very beginning of this month. Two backdoored versions of the Axios NPM library were published to the NPM registry. Axios is the most popular JavaScript HTTP client. It's in 80% of cloud and code environments. If your developers use JavaScript, they almost certainly use Axios. The malicious versions contained a hidden dependency called plain crypto.js that acted as a cross-platform rat dropper, targeting Windows, Mac, and Linux simultaneously. What makes this especially difficult from a detection standpoint is the malware dropper deleted itself after executing and replaced its own package.json file with a clean version. If a developer or security engineer inspected their node modules folder after the fact, they wouldn't find anything suspicious. There's no post install script, no malicious file. Running npm audit after the fact would come up clean. The only reliable forensic signal is whether your pipeline pulled those specific versions during that 3-hour window. Going into the technical details and attack chain, the staging detail is what makes this campaign technically impressive and operationally very alarming. The attacker published a clean, benign version of the dependency 18 hours before the attack. This lets the package build a short reputation history on NPM before the malicious version follows. It's not a random unknown package appearing out of nowhere. It's a package that's already been seen and potentially cached. Three OS simultaneous targeting is also noticeable. So pre-built payloads for Windows, Mac, and Linux deployed in parallel means this wasn't opportunistic. This was clearly precision planning, um, essentially trying to target every developer regardless of platform. Um, Another forensic tell is in the OIDC provenance metadata. Every legitimate Axios publish is cryptographically tied to a specific GitHub Actions workflow, and these malicious versions had no such attestation. They were published directly using the stolen token. So if your team uses NPM packages with OIDC provenance checking, this attack fails at the publication verification step. If you don't have that in your pipeline, you have no way to distinguish a legitimate release from a compromised one at the time of publishing. Um, Going on to the detection again here. So it kind of splits into two tracks for this campaign. Immediate triage for whether you were affected, and long-term hardening to catch future supply chain attacks. Um, Immediate triage is straightforward. Search your lock files. Searching for the lock files will show the specific versions that would have been pulled for specific time windows. Um, it was a 3 hour window on March 31st, from essentially 0:21 to 3:15 UTC time. I don't believe that's actually in the slide, but I can send that out with the slide deck as well. So you can search in your environment specifically for that. If you don't see anything pulled from the pipeline, then you are safe from this. However, on the long-term hardening side, uh, the detection signal that would have caught this is once again the OIDC provenance metadata. So every legitimate release from a major open source project should be cryptographically attested to a specific CI/CD run. If your pipeline enforced provenance checking, the malicious Axios versions would have failed verification check on install, and that is the control gap that this campaign exploited. Going to hardening and response for this. Um, I know I touched on this a lot, but obviously the OIDC provenance enforcement, I would highly recommend requiring this for all NPM package installs. Dependency pinning, so just pinning package versions in lock files and use npm CI instead of the npm install in pipelines. Um, Rotating and auditing all your long-lived npm access tokens, and lastly, IDE extension vigilance. So some developers were actually hit because IDE extensions automatically pulled this dependency. So I would just recommend auditing all of those approved extensions and restricting auto update behavior for these extensions. And we can move into the Q&A section now if anyone has any questions they'd like to ask.
Yeah, if you have any questions, feel free to drop them in the chat. I can read them or the Q&A section, whatever works.
Additionally, as well, my email is listed on this slide deck. So if you can think of a question now, but something comes up later, or if you have a more specific question, uh, please don't hesitate to reach out via email and I'll get back to you.
If no one has any questions, I can give you a couple minutes back. I will be reaching out with the slide deck and the recording from today. And yeah, if you have any questions, we can set something up and get Bryce to answer them. Thank you guys for joining. Have a great day.
Thank you.